so that we have it for people who were unable to attend. In addition, Jen was also a VolparaEnterprise software user for 3 years, which made her the perfect addition to our team. So now I'm going to let Jennifer lead you through our third and final Lunch and Learn session, evaluating compression through VolparaEnterprise software. So Jen, all yours.
All right, thank you very much, Susan. Can you hear me okay?
I can hear you just fine, and I can see your presentation screen just fine.
All right, great. So thank you all for joining us today for our third and final Lunch and Learn presentation. Today I'm going to be covering evaluating mammographic compression through the VolparaEnterprise software. The majority of you have heard a lot of the data that I'm going to be presenting today, but I do hope this presentation is going to remind you of the importance of compression and how to understand your own compression behavior. So with that, let's get started. We're going to cover 3 areas today. We're going to talk about the clinical impact of compression. We're going to talk about a new personalized approach to compression pressure. And we're going to talk about the use and performance of VolparaPressure clinical function. To start out, compression is critical to image quality. Compression benefits are that it can immobilize the breast to reduce motion blur. It can provide a thinner, more uniform breast, which helps to reduce scatter, improve geometry, and reduce superimposition and minimize the radiation dose to your patients. The technologist's goal with compression is to optimize breast compression to the benefit of the patient. Compression is critical to producing a good quality mammogram, but there is a lack of guidance. This vague guidance results in subjective application of compression. With this subjective application, techs subjectively apply their compression. We use the tautness method as technologists, or the finger touch method. That's the most commonly used way to determine how much compression we've used. Technologists determine how much compression is adequate for each woman and each breast. The results of subjective application is there's a wide variation among technologists in how compression is applied. There's also the possibility for under and over compression to occur. What we need in compression is a new approach. Is there another method available that can help objectively personalize compression? New evidence points to pressure for a personalized, objective method. So let's talk about that new personalized approach to compression. The principles of compression pressure is in physics, pressure is defined as force over a given area. In mammography, while we apply force to the breast, it's the pressure on the breast that determines how much that tissue is actually compressed. In the science world, when they measure pressure, it's measured in a Pascal. But due to the scale of values of things in mammography, it's actually measured in a kilopascal when we refer to it in the mammography world. Think of it similar to a gram versus a kilogram, or a meter versus a kilometer, or a kilometer. When you see kilopascals in mammography, or anywhere for that matter, you will see it represented as a small k, a capital P, and a small a, just like you see on the screen here. Pressure, or kilopascals, is dependent on the amount of applied force in decanewtons or pounds and on the contact area between the breast and the paddle. The formula for pressure is pressure equals force divided by area. The same force applied to a small-breasted patient or a large-breasted patient leads to different pressure results. There was a large study done in a Dutch screening program called the Holland et al. Landmark study. The research objective for this was to investigate if the level of breast compression can impact screening performance using pressure to characterize the level of compression. To do this study, they looked at over 132,000 mammograms, or 57,000 women, in 2D full field digital mammography, and they separated these patients into 5 separate pressure groups. From the Holland study, it was determined that pressure can be applied equally to different patient breast sizes. It was also determined that cancer detection rate is impacted by compression pressure. That cancer detection rate peaks or is most noticeable at around 10 kilopascals of compression pressure. If you use too high of compression, you're more likely to result in missed cancers. If you use too low of compression, it's more likely to result in higher recall rates, although sometimes low compression can also impact sensitivity or also have missed cancers if there's not enough compression. Holland's work indicates pressure significantly above or below 10 kilopascals of compression pressure is going to impact the mammographic performance. That means there's a range of forces that achieve an acceptable pressure range. The VolparaEnterprise software provides a target range of 7 to 15 kilopascals of compression pressure. If you are below that 7 kilopascals of compression pressure, it is going to be marked as low compression. If you are above that 15 kilopascals of compression pressure, we're going to say you have high compression. In general, with Volpara pressure, you will learn to apply force based on the patient's breast size to achieve that target compression. And you will learn what compression force provides that optimal pressure results for a given breast size. For example, here are the 3 different breast sizes: large breasted, medium or average breasted, and smaller breasted images. If you take an applied force of 17 to 37 pounds or 77 to 165 newtons of applied force on a large breasted patient, you're most likely to receive or to achieve, that in target compression pressure of 7 to 15 kilopascals. Same thing on the medium or average breasted patient. If you range between 14 and 30 pounds of applied force, or 63 and 135 newtons of applied force, you also are going to achieve that in target compression pressure of 7 to 15 kilopascals. On the smaller breasted patient, you're going to want to aim for 7 to 16 pounds of applied force, or 31 to 73 newtons of applied force. And again, you will then achieve that in target pressure for smaller breasted patients. So here's showing you a range of force that you can use to achieve that in target pressure that you want to aim for. So now let's talk about how you can look at this information with the Volpara pressure software. What is the use and what is the performance? First off, we at Volpara have this form that's going to show you newtons, decanewtons, and pounds. This is going to be very beneficial to any of you that operate on a machine that measures in pounds. So if you don't have access to this chart already, please reach out to your clinical trainer or reach out to Success Group at volparasolutions.com, and we will make sure you get a copy of this conversion chart. A lot of the information in VolparaEnterprise is measured in newtons or kilopascals. So if you do want this conversion, here's a great form for you to use. Just so everyone does understand what the conversion is though, approximately 4.4 newtons per 1 pound is what the conversion chart shows. With the Volpara pressure, this will calculate pressure based on force and area. There's a compression pictogram, just as you see here on the right, that is on both the technologist individual page as well as on the lead technologist for the overall team performance. This compression pictogram is going to show you the upper and lower threshold for that target compression. So just as you see here on the screen, you see the 7 kilopascals and the 15 kilopascals of compression pressure. Target range here, high compression percentage and low compression percentage. This is going to show you what percent of time you have hit high compression images target compression images or low compression images as a technologist, and as a lead tech, you will see the percent of time your entire department is achieving high compression, target compression, and low compression. Within the Volpara Enterprise software, whenever we talk about high compression, it's going to be represented by that hot pink or magenta color. Whenever we talk about target compression, it's going to be represented by that light blue color. And whenever we talk about low compression, it's going to be represented by the dark blue color. So keep those colors in mind because that will help you throughout the software to identify what images are high, target, and low compression. Now, what happens if you don't use enough compression? Well, if you have low compression on an image, the patient's comfortable. So that's a positive part of this. But unfortunately, your cancer detection rate is reduced if you do not use enough compression. You also run the risk of your patient moving more, and the X-ray dose to your patient is increased if you use low compression. So there's a lot of negative things to not having enough compression for your patient and for the images. With high compression, the positives are you have a less likely chance for your patient to move if you have too much compression, and your X-ray dose to your patient is decreased with high compression. But unfortunately, your patient's going to be a lot more uncomfortable, and the cancer detection rate is reduced. That was determined in that Holland et al. Landmark study that if too much compression is put on a cancer, you can actually cut off the blood supply to that cancer, causing that cancer to not even appear on your mammogram. Therefore, your radiologist is going to miss it, and of course, you're not helping out your patients. So you don't want to use too high of compression or too low of compression. With the Volpara pressure, we have scatter plots. These scatter plots are going to reveal each technologist's unique compression behavior. There are two separate scatter plots, one for your CC view as a technologist and one for your MLO view as a technologist. This provides actionable data to manage your clinical application. How you can monitor this is log in frequently. This will keep an eye on what your progress is. Are you moving towards what you want to achieve? With these scatter plots, each breast compression is plotted for size as well as for pressure. Every dot is going to represent an acquired image that you yourself have taken. The size across the bottom, or the patient breast size, is across the bottom. Use these guidelines to help determine what size patient breast is this. Your smaller patient breast sizes are going to fall between that 0 and 500. Your medium or average breasted patients, those are going to fall between that 500 and about 1200. And then your larger breasted patients are going to be that 1200 and greater area. So when you're looking at these scatter plots, whether you're on the technologist dashboard or the lead technologist dashboard, keep these numbers in mind because they will help you identify which patients are you over or using high compression, target compression, or low compression on, and will help you to be able to adjust from there. Each technologist's scatter plot is different, with some similarities useful for the clinical application. In the CC scatter plot, this may show that you have high compression mostly in your smaller breasted patients. In the MLO scatter plot, this could show that there's very few or not a lot of high compressions, but there are low compressions across all breast sizes. Usually, though, you're going to see more low compression in your larger breasted patients. Review your scatter plots to learn about your own compression behavior and again to identify how you're doing with this. How you can use this scatter plot is you can hover over any dot, just like this, and you can reveal the patient's breast size and the pressure result for that image. If then you actually click on that dot or any dot, you can open the study viewer just like this. When you open this study viewer, it's going to open up to that specific image. So you'll be able to see, is it a smaller breasted patient or a medium or a larger breasted patient, which you already knew from your scatter plot, but this helps you identify that size a little bit more visually. Then when you look to the right, you're going to see the data and the information for this specific image. The image that you have opened will be highlighted by this blue or teal colored box. In this box or in this study detail information, there is a section that's going to show you the patient's breast volume. It's going to show you the patient's breast thickness, and it's going to show you the patient compression pressure as well as compression force that you used. Here it is a little bit larger so everyone can identify what it is reading there. When you are looking at this data, you will be able to determine, okay, I used too much compression pressure here. Here's the compression force I used. On my future patients of this size, I want to reduce the amount of force that I used here so I can achieve that in-target compression pressure for my future patients. Same thing if it was the opposite. Of course, this would help identify where you were at, how much force did you use, and what should you increase to moving forward. For breasts that are about the same size, look at your other images in that target compression range, and that will help you understand how to modify your compression behavior. Which images have you taken? Are you over compressing, under compressing, or hitting that target compression? Also, in the technologist dashboard, you have access to a trend analysis. This trend analysis is separated by both MLO and CC views. It gives you a chance to see if you are improving on your compression during a specific date range. You also have the ability to remove high, low, or target compression from your graph to see how you're doing. When you look at these graphs on the right-hand side, you'll see your date range across the bottom. You are going to see high, target, and low compression here all on the same graph. But as I mentioned, if you click on, say, low compression and high compression, you can remove those from the graph and just identify how you are doing on your target compression. The desired outcome that you want to achieve with this trend analysis is that your target compression should be going up over time, and your low and your high compression should be going down over time. So now let's move into the lead technologist dashboard. If you're a lead tech and your techs either don't have technologist access to Volpara, or you want to help improve or identify areas that they can work on, here's a great place for you to look. In the lead technologist dashboard, there is a compression per technologist page. On that page, and I'm going to go out and show you it on our demo site, but you have the ability to look at compression pressure, just like the technologists have looked at, but a lead tech can also look at the applied force for each technologist. So they can see how many newtons of force is each technologist using for their specific studies. How you're going to do this is I recommend opening this in focus mode. Pick an image view and pick a technologist so you can sort down to just one person. Again, the numbers for patient breast size across the bottom are the same as I've already mentioned. Smaller breasted patients are 0 to 500. Medium are going to be between that 500 and 1200, and larger are going to be that 1200 and greater. When you are looking at this force, applied force information, the green lines going down here, that's representing about the medium or average breasted patient size. Look at what force range this tech used to achieve that in-target pressure for each breast size. So on the medium breasted patients, this line points to right down in here. This is about where she was hitting her target compression range. So that's about 70 newtons of force. You can also see up to about here is where she was still hitting that in-target compression pressure she wanted. So we're going to say that was maybe about 115, 117 newtons of force. So moving forward, this technologist knows if she aims between those numbers, she is more likely to stay within the target compression range on her average breasted patients. Same thing, of course, you can come down here and do it for smaller breasted patients or look at this for larger breasted patients. But you're going to want to identify where are the majority of the target pressure images and where is the higher end, and that will help you identify this information. Once you identify these numbers, share this information with the technologist. This will help her improve her target compression. If you are working on a system that is measuring in newtons, your lines are going to look more like this, straight across. You'll be able again to identify where is the starting point or the lower end of force that this technologist can use and where is the higher end of force that this technologist can use so she can better help identify what she needs to do for her patients moving forward. So with that being said, let's jump out of this for a moment and first into the technologist dashboard. So when we look at this technologist dashboard, I'm on the compression page here. You can see the percent of time that this technologist had high, target, and low compression. And then, as I mentioned, here's your chance to see her MLO, or sorry, she's able to see her MLO and her CC images. 0 to 500, 500 to 1200 is average, 1200 and greater is large. Take a look at these. Identify which ones are you over compressing, hitting target compression on, or low compressing. Move to the right. Up here is your trend analysis. When you click on the trend analysis, again, you'll be able to identify the MLOs versus the CCs. Where are you at? Are you improving over time? Change up your date range if you would like to. See if this is getting better. And as I mentioned, I can click on low compression and it's going to take that off of my chart. Click on high compression and it will remove that. And you'll be able to see, are you getting better with this specific area? Lead technologist, as I mentioned, there is this compression per technologist. Here is the applied pressure, which is the same thing that I showed you on the technologist dashboard. And here is where that applied force is. So if there's any lead techs on here, this is the slide that I love to look at, or the area I love to look at. Right at the top here, there's this little square focus mode. If you click on that, it's going to open it up here. So all of these dots are together. Come to your right, filter down to a CC or an MLO view, and you can filter to one technologist. Give it a moment, it's spinning. Once you do that, once it does come up on the screen as I want it to, it's going to show you exactly how this technologist is doing on hitting that target compression and what amount of force is she using. Again, medium breasted patients through here, I can see she's hitting target force right around here. That's about that 70 newtons I mentioned, and move up to about here. And I can see that's at about 115 newtons of applied force. So great way for you to really identify what is she using and how can she adjust moving forward on her future patients. So let's come back to the presentation here. Give it a moment. All right, so now what can you do to help adjust your compression? Well, to manage your clinical environment, start simply. As a technologist, set objectives and goals from your technologist dashboard performance page. What is your organization average? That's listed in purple. What is your average? That's listed in blue. Currently, the average compression for VolparaEnterprise users across the globe is 55.9%. And currently, the top 10% or 90th percentile are about at 69.3%. So compare yourself to there. Know where you stand and set realistic goals. Start with small adjustments, 1 to 3 pounds in either direction or 1 to 2 decanewtons in either direction, and review your results at least once a week. Start with your CC view. Based on your own data, adjust your compression higher for your larger breasted patients, adjust your compression lower for your smaller breasted patients, and always compare the left and the right breast. Apply the same compression force to both CC views until you learn what best force range for a given breast size you should use. In the MLO view, it's a similar amount. In your larger breasted patients, most likely you're going to need to adjust your compression higher, and in smaller breasted patients, you may need to adjust your compression lower. But again, compare the left and the right breast. Also in your MLO view, attend to positioning issues. Look at your detector height, your detector placement, and posterior LOQ folds. This can help you adjust the compression in your MLO views. Most importantly, discuss compression with your patient prior to starting the mammogram. The FDA website states that if a technologist explains what she is going to do during the exam, this can help prepare the patient for the experience and reduce her discomfort. If the patient understands the importance of compression and why it is needed, they are less likely to have an issue with the amount of compression you use. Make sure the patient understands that adequate compression can help aid in early breast cancer detection. In summary, Volpara pressure is the first generalized method for a personalized application of compression to optimize mammographic performance. Unique individualized data provides feedback and learning opportunities for techs to advance their skills. Here's an example of a tech. Before she started using VolparaEnterprise, she had low target compression and high low compression. And after a year's worth of using VolparaEnterprise, she increased her target compression to 61% and reduced her low compression to 35%. Thank you all very much for your time. I think I took us right about to the end. If anyone wants additional information on compression or about any of the Volpara products, please reach out to support@volparasolutions.com or successgroup@volparasolutions.com. And I believe now Susan's going to talk to you about the survey link.
Jennifer, thank you so much. Look at you. You got it right in just under 2 o'clock. That was great. Fantastic job. Thank you all for hanging in there with us. I'm going to now place the evaluation link in the meeting room chat. So if you want to click on the little thing that looks like a little chat message, you will see that has been shared there. Everybody that attends must complete this. You can also email me if you need the link sent to you via email. I can do that. Again, successgroup@volparasolutions.com will get it to you very quickly. So now people are kind of making comments, and that's great. We certainly appreciate that. We did not allow for a lot of questions because of time constraints. But please be sure before you leave that you click on the evaluation link. So with that being said, I'm going to stop the recording now. I'm going to thank you again one more time, Jen, and I'm going to hang out in the room for another 5 minutes or so. If anybody needs to unmute themselves, ask me a question. Again, I will continue to post the evaluation in the chat room. So thank you all, and everybody have a great day.